All right, let's talk about quadratic equations. In class, we learned about the quadratic formula to solve quadratic equations, and that technique is going to work all the time. It's always going to lead you to the solutions, whether real or imaginary. Now, there are other methods you've probably learned in your life, one of which is factoring. So we're going to do a little bit with that here, but I'm not going to emphasize it too much because, again, quadratic formulas really should be your go-to tool. Because factoring, first of all, doesn't always work. In some instances, though, it's pretty obvious how to factor. For example, here on the equation on the left-hand side of the screen here, factoring is really the way to go. So let me pull my pen tool up. So what's the common factor of the polynomial on the left here? It's x. So each term has a common factor of x, the greatest common factor, right? And if I factor that out, this is what I get. Now this is where you introduce something called the zero product property. If there's a thing, a product, a times b equals 0, then from that you can always conclude that a equals 0 or b is equal to 0. There's no way it could be, the case could be other than that, right? It has to, if the product of two things is equal to 0, then the possibilities are that one of them is 0, right? There's no other possibilities. So if I think of this as a and this is b, right, then I just immediately set x equals 0. That's one way that this equation could be solved. The other way this equation can be solved is by setting x minus 10 equals 0. And if x minus 10 is 0, by adding 10 to both sides, I get x is 10, right? So I get two solutions for this equation. And if you plug them in, you see that they work, right? 0 squared minus 10 times 0 is 0. And then 10 squared is 100 minus 10 times 10. That's 100 minus 100. That's also 0, right? All right, so that was pretty straightforward. Again, what we did is we factored out the greatest common factor and used this thing called the zero product property, right? Now let's try it here. So what is the greatest common factor that you see here? Again, it's x, right? And you see that it's essentially the same problem, right? Except for that what? I have a 1 over here, right? Instead of a 0. So what do you think is going to happen if I apply the zero product property here? Well, I'm going to get x equals 0, and then x minus 10 equals 0, right? And then I'm going to get x equals 10 over here like I did before. So are these solutions? Okay, let's check it out. 0 squared minus 10 times 0, well, that's 0, right? So is this a solution to the equation? No, it's not, right? 0 squared minus 10 times 0 is not equal to 1, right? Because 0 is not equal to 1. And likewise, 10 is not a solution, right? As we saw, 10 squared minus 10 times 10 is, of course, 0, and that's not equal to 1. So what happened here? What happened here is that this is not a proper application of the zero product property, right? Remember that the zero product property is this thing. It says that if you have a product equal to 0, then you can split that into two pieces and say, okay, each of my factors, set each of my factors equal to 0 and find solutions that way. Well, okay, I have a product like this, but the problem is this is not 0, right? This is not 0, so it's not working. The zero product property here is not working. Okay? So the reason I go through all this is that it's tempting to try to factor, right? It's try to factor that thing and then use the zero product property, right? But it doesn't work unless you have 0 on one side, okay? So how are we going to deal with this? what we're going to do is we're going to subtract 1 from both sides. And what's that going to give us? X squared minus 10x minus 1 is 0. And it doesn't matter, honestly, how you're going to solve the quadratic equation, right? If you're going to try to solve by factoring or whatever method you have in mind, actually, in almost every case, what you want to do is you want to get 0 on one side. There's only one exception to that, is if you're going to use the square root property. Okay, but otherwise, if you're not going to use the square root property, then getting 0 on one side of the equation is really step 1 for solving the quadratic equation. All right. So now that we have that, we can use the quadratic formula. A is what? 1. B is -10. C is -1. We'll calculate the discriminant. B squared minus 4AC is -10 squared minus 4 times 1 times -1, which is 100, right? Plus 4, right? Which is 104. So pulling out the quadratic formula, I get x is -10 plus or minus the square root of 104 over 2 times what? 2a, it's 2a, right? And a was 1, right? So that means x is 10 plus or minus the square root of 104 over 2. So you see, that's quite a bit of a difference. All right. So hope that helps.